In this video, we're going to go over section 9.4 from our textbook, which is on the graphs of our other circular functions. In the last section, we looked at the graphs of sine and cosine. So now we're going to look at the graphs of the remaining four circular functions. So we saw from previous sections that cosecant values are going to be reciprocals of our corresponding sine values. So cosecant x is going to be 1 over sine x. This tells us if sine x is equal to 1, cosecant x is equal to 1. And if sine x is equal to -1, then cosecant x is equal to -1. And by similar reasoning here, we have this. If sine is in between 0 and 1, then cosecant x is greater than 1. And if sine is in between -1 and 0, then cosecant is less than -1. Additionally, when sine x approaches 0, cosecant x is going to get larger and larger. And we can see this just by the form of this function here. If sine x is getting closer and closer to 0, so for example, if we had that sine x was equal to 0.01, this would be equal to 100. And if we let sine x get even closer to 0, so say 0.001, this would give us 1000. So we can easily see just by the form of this function here that as sine x approaches 0, our cosecant function is going to get bigger and bigger. So the graph of our cosecant x approaches the vertical line x is equal to 0, and in fact the vertical asymptotes are these lines here. And this is because sine of x is going to be equal to 0 when x is equal to some multiple of pi here. We can do a similar analysis for secant x. We know that secant x is the reciprocal of 1 over cosine. So, by similar reasoning here, as cosine x approaches 0, secant is also going to get larger. And we know that cosine of x is equal to 0 when x is equal to 2n plus 1 multiples of pi over 2. So this tells us that our vertical asymptotes are going to be the lines here. All right. So this brings us to the graph of first our cosecant function. Since the vertical asymptotes are these lines here, our domain is going to be all x such that x is not equal to this here. Our range is going to be all the output values between -infinity and 1, and then 1 and infinity. And here are some properties of our graph here. And then our graph is given by this guy here. So notice we have our sine graph here in pink and our cosecant graph here in blue. So as we'll see in the next several examples, we're actually going to be using the graph of sine x to graph our cosecant function. Also something to note here that the range is going to be -infinity up to -1. In this case, that is our amplitude for our function, which we represented with A in our past videos. All right. Similarly, we have the graph for our secant function here. We have our domain here and our range here. And similarly, our range is going to be given by this here. And we have our graph of our cosine x in pink, and then the graph of our secant function in blue here. And so again, we're going to be using our cosine function to graph our secant functions. So this brings us to the guidelines for sketching graphs of secant and cosecant functions. So we want to graph something of this form. What we're going to be doing is using the corresponding sine and cosine functions in order to graph them. Then we'll sketch the vertical asymptotes with equation x is equal to k, so where we have an x-intercept of our guide function or our sine or cosine functions. Then we'll sketch the graph of our desired function, which is going to be our secant or cosecant functions. by drawing our U-shaped branches between our adjacent asymptotes. And we saw that those occur like this here for each of these graphs. Now the branches will be above the graph of our guide function when the guide function values are positive, and will be below the graph when the guide function values are negative. So for example, our guide function on this guy, cosine, this output is positive, positive 1, so our branches are going to be above our x-axis. And here this output is negative 1, so here our branches would be below the x-axis. Alright, so let's look at an example here. We want to graph y is equal to 2 secant 2x. So what we'll do in this case is use our guide function, which is going to be 2 cosine 2x. Here we can see that a, our amplitude, is going to be 2. B here is also going to be 2. And so this tells us our period, which if you remember from the last video would be 2 pi over b. So in this case, our period is going to be pi. And so what we'll do is we break our interval into 4 equal parts here. So our interval on this side is going to be 0 to pi. Breaking this into 4 equal parts, we have these points here. And doing the same thing on the negative x-axis here, we get these points here. Now what we want to do is evaluate our function 2 cosine 2x at each of these points here. So first let's evaluate this at f of 0. In this case we'll get 2 cosine 2, 0. So this will give us 2, since cosine of 0 is going to be 1. So when x is equal to 0, we have 2 there. Now when x is equal to pi over 4, we'll get 2 cosine of 2 pi over 4, which is going to be 2 cosine pi over 2. We know cosine of pi over 2 is going to be 0, so this guy will be equal to 0. So we have that point there. Repeating this process for pi over 2, we will get 2 cosine of 2 times pi over 2. This will be cosine of pi times 2, so it'll be negative 1 times 2, so we'll get negative 2 here. And lastly, we have 2 cosine of 2 times 3 pi over 4 here. This will give us 0. And then we'll do the same thing for pi here. We'll get 2 cosine of 2 pi, which we know is going to be 1 times 2, so we get 2 there. So plotting these points, we have this, and I should move these out of the way so that we can graph this. So at pi we have 2. Now repeating this process for all of our output values on our negative x-axis here, we'll get negative pi over 4 gives us 0, negative pi over 2 gives us negative 2, negative 3 pi over 4 gives us 0, and negative pi over 2 gives us 2. So what we've done here is graphed our guide function, or our cosine function, which was the first step in our process for graphing secant and cosecant functions. Next, what we'll do is we'll sketch our vertical asymptotes. So these occur on the x-axis at our x-intercepts here. So we have an asymptote here. Here. And here. Right? Then our next step, what we want to do is sketch our U-shaped branches between our asymptotes, keeping in mind that the branches will be above the graph of the guide function when the guide function values are positive, and below when those function values are negative. So we'll start from left to right here. our guide function cosine, this output value is positive. So our branch is going to be above our x-axis, connecting right here. At our next point here, our function is negative, so our branches are going to go in this direction here. Repeating this process, we get this, this, and this here. Alright, so this will be our graph in green of our secant function here. Now let's do the same thing for a cosecant function. In order to graph this guy, what we want to do is use the guide function or our sine function. So we first want to graph sine of 1/2 x. In this case, our amplitude is just going to be 1. Our b is 1/2, so this tells us our period is going to be 2 pi over 1/2. This is the same as 2 pi times 2, so our period will be 4 pi. Alright, so again what we do here, we have a 2 period interval. This is our first period here. We'll break this guy up into 4 equal parts, and then we'll do the same thing for our second interval here on the negative x-axis. Now what we want to do is evaluate our sine function at these points. So plugging in 0 into our function here, we'll get sine of 0, which is equal to 0. For pi, we'll get sine of pi over 2, which gives us 1. For 2 pi, we'll get sine of pi, which is going to be 0. And then for 3 pi, we'll get sine of 3 pi over 2. And we know that's going to be negative 1. Okay, so we'll plot these points. Move that over. So we have a point here at the origin. At pi, we get 1. 2 pi, we get 0. 3 pi, we get minus 1. And then at 4 pi, we'll get sine of 4 pi over 2. So this will be 0 here. Now doing the same thing on our negative x-axis. At negative pi, we'll get negative 1. At negative 2 pi, we'll get 0. At negative 3 pi, we'll get positive 1. And at negative 4 pi, we'll get 0. So this is the graph for our sine function. Alright. Now our next step is going to be to draw the asymptotes for our cosecant function. These, remember, occur at the x-intercepts. So we'll have one here at minus 4 pi, minus 2 pi. We'll have one on our y-axis here at 2 pi, and then the last one is at 4 pi. Right. Now we'll draw our branches in between these asymptotes, keeping in mind the values of our guide function of our sine function here. At this point here at our amplitude, we have it's positive, so our graph's going to look like this here. At negative pi, our graph's going to look like this here. At positive pi, our graph's going to look like this. And lastly, at 3 pi, our graph's going to look like this here. So that would be the graph of this cosecant function here. So far we've looked at the graphs for our sine, cosine, secant, and cosecant functions. Now we're going to look at the graphs for the remaining two trig functions, tangent and cotangent. So the domain of a tangent function is given by this guy here, and this is because the graph is going to be discontinuous whenever x is equal to 2n plus 1 multiples of pi over 2. Now we know this because, remember, tangent is going to be equal to y over x, which is equal to our sine and our cosine values. And we saw from earlier that cosine x is going to be equal to 0 whenever x is a multiple of, or a 2n plus 1 multiple of pi over 2. And since we can't divide by 0, whenever cosine is equal to 0, our tangent function is going to be discontinuous. So this will happen at 2n plus 1 multiples of pi over 2. And this is why we have our vertical asymptotes at minus pi over 2 and pi over 2 here. Now the shape of our graph looks like this here, where our output values are going to be all real numbers. So our range is going to be all real numbers here. Now the x-intercepts are going to have x values of this form here. The period is going to be pi, and the graph is going to have no amplitude since there are no minimum or maximum values, like how we saw with our sine, cosine, and secant and cosecant functions. Now on the other hand, we have cotangent here. In this case, the graph is going to be discontinuous at multiples of pi because cotangent is going to be 1 over tangent. So this is going to be cosine theta over sine theta. So in this case, this function will be discontinuous when sine is equal to 0 because we can't divide by 0. And we know that that occurs at multiples of pi. So we have our vertical asymptotes when x is equal to 0 here and when x is equal to pi. The x-intercepts are going to have x values of this form here. Our period is going to be pi, and again, we're not going to have an amplitude in this case. So this brings us to our guidelines for sketching graphs of tangent and cotangent now. So the period is going to be of the form pi over b. And to locate the vertical asymptotes that we just saw in the last two slides, we'll solve the following equations for x. So if we have a tangent function here, we'll set bx equal to negative pi over 2 and solve for x, and do the same setting bx is equal to positive pi over 2. For cotangent, we'll set bx is equal to 0 and bx is equal to pi and solve for x. Our second step is to sketch the two vertical asymptotes that we just found by doing this here. Then we'll divide the interval formed by these asymptotes into 4 equal parts, and we'll evaluate the function at each of these points that we found in step 3. The last thing we'll do is join the points with a curve approaching the vertical asymptotes. So let's look at an example of this here. We want to graph y is equal to tangent 1/2 x. So in this case here, b is equal to 1/2. So this tells us our period is going to be equal to pi over 1/2, which is equal to 2 pi. Now our bx here is 1/2 x. So in order to find the asymptotes, we're going to set 1/2 x equal to negative pi over 2. This gives us x is equal to negative pi. And to find the other vertical asymptote, we set bx to positive pi over 2. Solving for x, we get positive pi here. So these will be our two vertical asymptotes. Now our next step is to divide this interval between these two vertical asymptotes into 4 parts. And so that's what we did here. We have this point pi over 2 and this point negative pi over 2 when we do so. And now we want to evaluate our function at these 2 points here. So f of pi over 2, we'll plug this into our function here. So we'll have tangent of 1/2 times pi over 2. So this will be tangent of pi over 4, which is going to be sine of pi over 4 over cosine of pi over 4. So that'll be root 2 over root 2, which gives us 1. And then similarly, for negative pi over 2, we'll get tangent of negative pi over 4, which will give us negative 1. So plotting these points here, we have 1 there, 1 here. And then what we want to do for our last step is draw a smooth curve connecting these points, approaching our asymptotes. Alright, so that would be the graph of tangent 1/2 x here. Now, Similar to what we saw in the last several sections, we can graph these trig functions using our vertical or horizontal shifts. In this case, for this example, we have y is equal to tangent of x minus pi over 4. In this case, our graph is going to be shifting pi over 4 units to the right. We have a phase shift here. Now in this case, b is going to be equal to 1. So this tells us our period is just going to be equal to pi. Now for our asymptotes in this case, we know that our asymptotes are always going to be some multiple of pi over 2. Now if we just had the function tangent x, we would have our asymptotes at exactly minus pi over 2 and pi over 2. But since we're shifting our function pi over 4 units to the right, this means our asymptotes then are going to be shifted pi over 4 units to the right. So this tells us our new asymptotes are going to be minus pi over 4 and 3 pi over 4. Alright, so we'll draw these asymptotes here. Minus pi over 4 and 3 pi over 4. Now again, we want to break this interval up into 4 equal parts, so that's what we have here. And then now we're going to want to evaluate our function at these points here. So first we'll evaluate this at pi over 4. Doing so, we'll get tangent of tangent of pi over 4 minus pi over 4. So this will be tangent of 0, which is going to give us 0. So we'll have this point here. Doing the same thing for pi over 2 here, we'll get tangent of pi over 2 minus pi over 4. This will give us tangent of pi over 4, which will give us 1. Alright, and let's plot another point, see what happens when we plug 0 into our function. We'll get tangent of 0 minus pi over 4, so minus pi over 4, and this will give us negative 1. So we'll have this point here. And so lastly, we will connect these guys as we approach our vertical asymptotes. So that'll be the graph for tangent of x minus pi over 4. Alright, so the last example we'll look at is this one here. We want to graph 2 cotangent of 1 over 4x. So in this case, remember our tangent and cotangent functions don't have any amplitude because we don't have any minimum or maximum values. So although we have a 2 here, that's not going to be our amplitude. We do see though that our b is going to be 1 over 4. So this tells us that our period is going to be pi over 1 over 4, which is equal to 4 pi. Now in this case, when we want to find our asymptotes, what we want to do is set our bx equal to 0 and pi, and then solve for x. So bx is 1 over 4x. Setting that equal to 0, we'll get that x is equal to 0. And then setting our bx equal to pi here, we'll get that x is equal to 4 pi. So this tells us our vertical asymptotes are going to occur on the y-axis here, when x is equal to 0, and when x is equal to 4 pi. Now dividing this interval into 4 equal parts, we get these points here. And so we'll evaluate our function at those points. So we'll get 2 cotangent of pi over 4 when x is equal to pi. This is the same as 2 times 1 over tangent of pi over 4. We know that tangent of pi over 4 is just going to be 1, so this will be 2 here. So when x is equal to pi, we have 2 there. And when x is equal to 2 pi here, we have 2 times 1 over tangent of 1 over 4 times 2 pi. So this will be tangent of pi over 2. This is the same as 2 times cosine of pi over 2 over sine of pi over 2. And since cosine of pi over 2 is equal to 0, this will be equal to 0 here. So we'll have this point here. And then lastly, we'll evaluate our function at 3 pi. Doing so, we'll get 2 times 1 over, we'll get tangent of 3 pi over 4. This will be equal to 2 times cosine of 3 pi over 4 over sine of 3 pi over 4. Cosine of 3 pi over 4 over sine of 3 pi over 4, this will give us negative 1. So we'll get negative 2 here. So we'll plot that point right about there. Now drawing our curve, we'll get this here, which will be our graph of this cotangent function. Alright, so that'll be it for this video.